Hey, I'm Mark Schultz with DigitalAircraft, and welcome to another energetic discussion on blockchain and aviation. And you might ask yourself, why do we continue to do this? We're into week number 6. And let me tell you why, is because I am passionate about digital and I'm passionate about aviation. And so many of you were interested in knowing about blockchain and aviation and how it all fits in that we decided to have this 8-week series where we're focusing on blockchain and aviation. So here's the lineup for this week. This week, I have a guest where we're going to be talking about uncrewed traffic management and air traffic management. It's my guest from Cranfield University, which is a very advanced university, which is focusing on technology and aviation. It's very exciting. And then Friday, I have another great interview, which is occurring on NFTs for jets with a company called eVTOL. You're not going to want to miss that. So today's discussion is going to be focusing on blockchain and how we're optimizing air traffic management. I have a guest here today who is a professor. He's a doctor and a professor at Cranfield University. He has background in IT, background in air traffic management, and now he's passionate about digital and its implementation within aviation surrounding blockchain. We're going to have a lively discussion here today about how that fits in. Let's go ahead and bring him in today.
Hi,
hey,
Mark.
Dimitri,
Hi, everyone.
Welcome. Yeah, glad to have you with us.
Glad to be here. Thanks for having me.
Yeah, Dimitri, tell our viewers where you're located today.
So I'm located in beautiful Cranfield University and Airport. As you can see in my background, always want to promote our assets. That's 50 miles north of London, in between Cambridge and Oxford.
Perfect. Hey, we're going to get into more details about that, but because I know people want to know, where's the think tanks happening in the world and where are the ideas coming from in technology and aviation. So it's going to be an exciting discussion. Hey, as we're getting going here, I already see we have all kinds of people that have already joined the broadcast. Thank you for joining. And please share this live stream. I see that we had so many people sharing it already, and that really gets the word out. And, I am really passionate about digital and aviation. Hey, Dimitri, I see it's your passion too, right? You love aviation and digital, right?
Absolutely. Absolutely.
Yeah, good. And so everybody out there, just share the stream. Help us get the word out. Help us help other people to be successful in this space. And also, as always, I love to know who's watching and where you're watching from. And I like to recognize people and just give you a shout out. So if you're watching today, just there's a comment box down below. If you would just put in, where you're located, I would really appreciate it. And we'll give you a shout out. And then during the broadcast, if you have any questions today for Dimitri, I prefer really, really hard ones for him, just to make him get a little bit uncomfortable. Send him a really hard question, put it into the box, and we'll see if we can answer your questions as well. Thanks for joining again. I really appreciate it. And let's jump off into a good conversation here. Dimitri, tell us a little bit about your background. I mean, what is it? Who are you and what do you do? I mean, what's your background?
So yes, thanks for that. So I started as electronic engineer. I did all my studies in the UK, and then I stumbled across air traffic management. After my PhD, I did a PhD in satellite navigation and integrity algorithm in flight management systems, basically how aircraft can self-navigate using GPS and other such satellite systems. And I was fortunate enough to get into the graduate program of National Air Traffic Services. Basically, that's the air navigation service provider that controls most of the UK airspace, definitely the en route, the FAA of the UK in a sense. And I was very fortunate to have bosses that got me passionate in air traffic management. That is a very, very niche industry, actually, which I didn't know much about, but actually is a very important cog in the whole aviation ecosystem. Right.
Yeah, it really is very niche. How did you happen to choose satellite navigation and FMSs, flight management systems? Why did you choose that for a PhD study?
It's all about the path of life, right? Luck. I think I just stumbled across it. I had a number of options, and they offered me the job at that point. And I think a bit my life was at that path. I mean, I'm curious. I think we are all curious. We all adapt to opportunities, and the opportunity was there.
Very good, very good. So, so you ended up going into studies at Cranfield University, or I don't think you went into studies. Where did you actually study at?
So I studied at Imperial College London, my PhD, and then I started working in London for NATS, the National Air Traffic Services, close to Heathrow. So Heathrow was one of our main customers. I deployed air traffic management systems all across the UK, in UK airports, how you improve the systems, improve the efficiencies of what the air traffic controllers do, the pilots do, how they communicate together, and how the whole system works together in a collaborative way.
Okay.
After,
well, how did the conversation of blockchain, enter into that? How did you get involved in that?
That came a bit more recently, to be honest, although blockchain exists for quite a few years. I was in the industry, as I said, working for NATS. Then I went to Gatwick Airport. And 2.5 years ago, I joined Cranfield to head the Advanced Air Mobility Research Group, really pushing innovation and trying to push the boundaries of innovation and how we deploy those systems. Because air traffic management, as aviation, historically is a very safety-critical operation, very slow to implement change just because of this safety-critical context, right? To test, validate, meet the regulatory requirements, meet the safety requirements. It takes time to implement change, but also to get the users, like the air traffic controllers and the pilots, to accept change as well. Yeah. So I came to Cranfield exactly to do that, to be able to push those boundaries in a way. As you can see, I have the airfield behind me, so we can do quite a lot of beautiful stuff, from concept development to actually deploying things and testing them in a controlled operational environment.
Well, let me ask you this, Dimitri. You brought up the word advanced air mobility, so we can give people context of the things that you're focused on right now. Mm-hmm. Can you tell me a little bit more? What do you call advanced air mobility?
So there is a very specific definition from the US of advanced air mobility, right? The way we use it in Cranfield, we actually put it as an umbrella term to define everything that is increased automation, increased autonomy in air traffic management, increased decision support tools, as I said, for air traffic controllers and pilots, but also integrating safely all these new aerial vehicles that we are seeing that are more common nowadays. These drones for good, uncrewed aerial vehicles, new electric vertical takeoff and landing systems, the new air taxis, and all these futuristic, in a sense, aerial vehicles to share the airspace of conventional air traffic, which, as I said, is very safety critical minded.
Yeah, we have such a growth and an expansion, of aviation when you consider advanced air mobility, and it creates certain challenges within the industry. So maybe we shift our conversation to just that. What do you see as the biggest challenges that we have in the industry today, given the context of we're talking about the growth of aviation and stretching of the air traffic system and the introduction of advanced air mobility? What are the biggest challenges that we have out there in the industry today?
Okay, there's a number of challenges, but I'll just try and focus on 2 or 3 that I want to touch upon today. So first of all is really transforming the current air traffic management system, right? So how you alleviate workload of air traffic controllers that is also already kind of saturated, because the systems they use are disparate, different, so meteorological data, radar data, all this kind of different information they need to ingest, assess, understand, and then instruct to the pilots and others what to do. So that's number 1. Number 2, the change management, how you implement new systems, new technologies to optimize those processes in a context where those regulatory frameworks don't exist yet. So as we know, the last couple of years, the regulators have done a great job to actually catch up to technology. But I think this is the opportunity and the beauty, having all these kind of new entrants, new technology developers actually pushing and trying to challenge the current status quo of air traffic management.
So we find ourselves, I think we have another picture, and if you take all the different systems and things that are being integrated and are being brought into the controller, basically sitting in front of him is quite a complex kind of an environment, right?
Absolutely.
So Dimitri, what are we looking at here right now?
So we see a very typical scenario of an air traffic control tower, right? Where the controller needs to look outside the window to actually see and have a situational awareness of what's going on the airfield, but also understand all the different contextual factors. So weather, met information, radar, any traffic that's coming in, that's going out, talking to their colleagues, and so on. So they need to really understand, assess a number of different information feeds, and then instruct and take executive action. So what we're trying to do with increasing automation and autonomy is help and alleviate that workload from the controller to be able to just have a ratified information feed that is combined, that gives them exactly what they need when they need it, as opposed to them choose what is important for that particular executive decision that they need to do.
Yeah. So what you're telling me is that we have all these information sources that are coming in, and we have all this different attention that has to be given to, aircraft and safety and meteorology and ground control and, air route traffic control and just complex information, radio handling. And so today, are most towers still existing like what we see here now in front of you?
Most if you take the average across all the world, I would say yes, but there is like this new technology called the digital tower, basically where you kind of digitalize the outside view of the control tower. So Heathrow has one, we have one at Cranfield, London City, and others in the world. But actually that allows us to then digitalize all that information and be able to display directly on the screen exactly the information that the air traffic controller needs and wants, as opposed to have to go and fetch it from other screens.
Perfect. So let's pause here for a second, because I want to come back to that, because that's the next segment here. You brought that up perfectly. I like to recognize people that are out there watching. We have Jean-Marc with us today. He's continuing to follow that. We actually have their company, Skythread, which is going to be coming on next week on Wednesday, I believe. Next week. And so I want to welcome you here today. And sometimes we get people watching and their names don't come through. I'm sorry, but you have somebody in Colorado who's, giving you a shout out. Dimitri, thanks. And we have Lorenzo. Lorenzo, thanks for joining us. I appreciate you watching. Says great initiative. Let's see, we have a guest here from Birmingham, and says great session so far, and points out safety is a key part. Dimitri, would you agree with the safety?
100%. 100% safety is our DNA. Never change that. That's a fundamental pillar of air traffic management.
Yep. And then we have Kamal, who's joined us here. Flight planning and tracking, considering different players, data feeds, very, very complex. So yeah, I didn't even bring up the aspect of flight planning, but we have flight planning and tracking and all those different pieces, that integrate, as well as maps and airways and radars and, all those things. So wow, we're creating a very complex environment. Now, Dimitri, I know you have to answer this, yes, but I'm just going to ask you, do you believe the current air traffic system today is safe?
Yes.
Yeah, of course.
But stretched. And so that's where I wanted to go with that, is that it's stretched, and we see it's stretched because it was only just a few weeks ago, it was last month in June, that Heathrow Airport said, wait, we're over capacity. Stop scheduling so many flights, and so we know the system is stressed, and we see that anytime there's a weather event or anything, that there's an argument between the airline and ATC on whose fault it is, and they say it's your fault, and so we know that it's stretched. We don't have to look very far to see that it's stretched. Now, enter advanced air mobility, right? And we're going to have a significant growth. And one of our previous guests last week said that we're expecting like a 10x growth, in traffic from advanced air mobility. So the question is, what do we do about that? Now, you introduced the idea of digital. Let's go into that a little bit. Let's talk about that. Is that how can we use artificial intelligence and maybe distributed ledger technology, in order to be able to improve optimization? Tell us a little bit of the benefits of doing something like that. Yeah, I'll just touch upon that. So we are expecting a tenfold increase in air traffic movements from all these new aerial vehicles. Until a couple of years ago, controllers didn't want to hear anything about drones. We don't really care about them. We don't want to see them. But actually, that is kind of changing the attitude. situational awareness is the most important thing, right? But then for that increase in air traffic movements, you can't have anymore the human in the loop always controlling. So overseeing, yes, but not controlling. Hence why we want to introduce more autonomy, more automation. And of course, we put that under the umbrella of AI, more intelligent decision making, or decision support tool for the end user to do decision making.
To reduce their workload.
To reduce their workload, to allow the full potential of those new aerial vehicles, drones for good, and so on, because the current system is not scalable as it is. You won't be able to have,
all while improving safety, like you just said, right?
Always, and that's really the crux of it. Improve safety, improve capacity, improve resilience through automation, autonomy. But then the challenge with that is that we don't necessarily have the way to certify, we don't have the safety requirements to certify the autonomous systems, more intelligent systems, right? And this is where the regulators are playing catch up. There've been a couple of requirements being developed in the last couple of years, but the whole idea of then deploying those systems to be able to routinely fly in an integrated mode are still in the process of being developed and deployed, right? And what we're seeing here,
Dimitri, my experience in working with regulators over the years has been that, there's two different groups of people. There's those that go to the regulators and say, tell us what to do. And there's those that go to the regulators and say, these are our recommendations on how we can provide efficiency and safety and, and growth in operations, and collaborate with the regulators in order to be able to use the knowledge of industry and satisfy the needs of the regulatory agencies. And by working together, you can create growth and guidelines which work for all. And I really like what you guys are doing in doing research and bringing out, the methods and the solutions, and not going to the regulators and say, give us regulatory guidance. I think that's the right way to do it.
Absolutely. Because at the end of the day, the expertise is in the industry, right? Is from the technology developers, but then not always. And this is where one of the challenges are as well. Like all the new entrants, new UAV operators, etc., they usually lack the knowledge of how you go and certify a product, or how you go and get regulatory approval. Clearly, those requirements are missing, but the process by which you actually engage with the regulator is missing. And actually, lately, the regulators are taking a bit of a more proactive approach. And for example, one of the projects we've had all through the Future Flight Challenge that we'll discuss in a bit is the regulator is actually now more embedded within the project team to actually be able to inform themselves of where the industry is going, what they're developing, taking all those lessons learned to then inform their guidelines and guidance, which we've seen in a couple of developments in the UK Civil Aviation Authority of late.
Okay, so you brought up a word. I'm going to go back to that AI chart in a minute, not yet, but I'm going to go back to it. But you brought up a word, the Future Flight Challenge. I know that you were involved in an initiative to take a look at, future flight and technology. Can you explain a little bit about what that is?
Absolutely. So Future Flight is Future Flight Challenge is a program by the UK government, UK Research and Innovation, to actually develop the future airspace, future integration of aerial vehicles into the conventional airspace. What that means is you have so many different components of that ecosystem, from the aerial vehicles themselves, or the intelligence, the technology on board, the management of those systems, so the air traffic management and uncrewed traffic management and other components, the connectivity, the ground infrastructure, pretty much a lot of elements. So that program is actually seeking to develop all those different components through a number of projects. I think there are 42. Oh, sorry, there were 42 in phase 2 that is closing now, and there are 17 for the next 2 years, phase 3, to be able to then be able to deploy those systems routinely in our space.
So it's a industry, public-private, university kind of a partnership to bring together knowledge and experience, regulatory considerations, research considerations, industry experience, bringing all those things together to be able to look at future flight challenge and how we can optimize, through the use of technology, given the growth in the industry. Is that correct?
That's exactly spot on, actually. Yeah. So it's a match funding program where government has put 125 million pounds to fund, but then that was matched by all these different organizations from academia, industry, small and medium enterprises, startups.
Yeah, fantastic. Good. So I want to go back to that thought again. So we had a chart that I had up before, we maybe put up a little bit early. I want to bring it back up again.
Yeah.
And so given that we're looking at technology, and one of the things that's been considered is distributed ledger technology, blockchain. So how does that fit into the idea of future flight?
Yeah, so we were part of a project with 13 different partners. And that is actually the brainchild of a very good friend of mine, Simon Brown from EasyJet. Right now, he used to be Tech Tower, and he was in episode 9. I really recommend you to go and look at this for your audience. But basically, that was a brainchild of how we can implement distributed ledger technology, blockchain, in aviation data distribution, right? So how we can make it easier for new entrants and not such a high barrier to entry as the current system is, how to make it more efficient, more secure, and safer. And from our side in Cranfield, so I work for the Center for Autonomous and Cyber Physical Systems, we brought all the autonomy, right? Automation. And that chart really shows the benefits and the congruence between those two, basically how those two new technologies that we have right now that will transform that ecosystem and will allow us, one, to scale, two, to be able to be safer and have both of those worlds together. So both of those technologies are clearly different technologies, but actually they have mutual benefits. So if you see on the left-hand side, AI, so AI for blockchain or distributed ledger technology, you have all those benefits of increasing security, governance, performance, scalability, and so on. So why is that? Is actually you can use AI to be able to check things like anomaly detection, adversarial attacks against the blockchain, against the DLT, which already are robust, but actually you can use systems like AI and machine learning to be able to detect underlying attacks and underlying issues like data corruptions, and so on. One of the things Simon talked and Matt, episode 10. So both of them were part of this this program, Flight to Plan. Is actually they were bringing all this blockchain technology to be able to show all this immutability of data, provenance of data, traceability, and so on, to be able to ensure that the new system, distributed as well as the current system is, but actually is much more efficient in the security side of things. On the left-hand side, then, how DLT then help AI? AI, in a sense, in general, needs data to gain, right? Needs data to understand what is going on. But then AI in general, the fundamental techniques right now are a bit black box. So we don't really understand how those decisions, how those recommendations, how those outputs are calculated and are presented. So what DLT can do is actually make sure that there is traceability of that data. So all the training data is stored on the blockchain and then used by the different stakeholders as they need. So you have much more availability of the security, much more trustworthiness of where the data comes from, making sure that it's not corrupt, that it doesn't affect the AI at the end, and actually allows transparency. And that's a keyword, transparency to the end user, because the air traffic controllers and the end users that have the licenses, basically, and they are on the hook if something goes wrong, to be honest, they need to understand exactly if they can trust the system. So DLT provides that.
So interesting is basically, if I could sum that up, you're saying that we take the best of distributed ledger technology, blockchain, and the features of that, and we combine that with the the knowledge and the machine learning and all those different aspects of advanced capabilities that we talk about, you put those two together, and now we have the benefits of both, which create even more synergy to give us, better decision-making, better knowledge, better information, better transparency, better security, better availability of data, and all those things that come from combining the two. Is that right?
Exactly. And most important, traceability back, because if something goes wrong, you need to go and investigate, right? And that's one of the fundamental things in air traffic management. If something goes wrong, you go back and investigate what has happened. And this DLT for AI actually allows that, as opposed to having AI just doing its own thing.
That was a good chart. Yeah, I really I appreciate that. So as we continue on to the next part of the discussion, let's just maybe talk about some of the benefits, of that. Maybe we bring up one more picture that we have, I think, before us. So what can you tell us about how all this fits together, right now?
It's a very elaborate diagram. And actually, I need to give credit to Dr. Carolina Sanchez Hernandez, who was part of Cranfield before and worked with us in Flight to Plan. She designed that. But basically, what this tries and shows is exactly how those two worlds meet together, right? So all this machine learning model pipeline is all the different tools that air traffic controller might have, or a UAV operator might have in its ground control station, right? So things like conflict detection and resolution, which is one of the fundamental pillars of how we actually have the full unlocking of that airspace, and where you identify the different data items that are produced from different stakeholders. So we have airports, airlines, air traffic, air navigation service providers, network managers, so the organizations that actually control or manages the demand across the EU. So all of those data items are not always available to everyone, right? So you need to understand which one is good to use, which one is more important for those specific tools, which we used in this context, conflict detection and resolution, but there's other things like we talked about before, flight planning, radar, other stuff. So what this is trying to show is that we can have this backward propagation of key data and features that are going from the model pipeline to the blockchain adapter, and informing back to the blockchain actually the internal data items that needs to be more secure, more agreed upon across all the stakeholders to be able to inform the model itself. So it's actually a feedback loop from the AI model and the tools that are being developed back to the blockchain, and how the blockchain needs to have more consensus, more agreement, and more checks on specific data items than others that are less important.
So Dimitri, you've shown us a view here of how things can fit together. And so let me just ask you this, are we talking about something that's conceptual now, or are there people working on implementing these approaches? Or tell me what's the state of the industry with respect to using blockchain and actually implementing of it in air traffic management?
So we've developed, as part of the Flight to Plan consortium, 13 partners. I'll name them later, but we also produced a white paper on this, exactly how we use DLT and AI for the UTM integration into air traffic management. We've developed exactly that model. I must admit, most of the work was done on the blockchain adapter, which is not really shown here, but you can see there's quite a lot of things going on in that small piece of work. So all of that has been developed, not necessarily as an example for the conflict detection and resolution, but for flight planning and delay prediction. So Flight to Plan was exactly this. So how we ensure that aircraft fly to their scheduled plan, because if they come later or earlier, it stretches and it puts difficulties in the overall system. So the punctuality is very, very important. So actually developed that framework has been developed. We have a repository of the code, courtesy of CETA an airline broker and tech tower, a startup working on these safety critical issues for aviation data distribution. So those exist.
Yeah,
right?
and
So
I
we've
understand they were
developed that.
actually used to conduct flights within live UK airspace, right?
Exactly. So we had Heathrow, we had live data.
Yeah.
So we've demonstrated the feasibility of that, right? What hasn't been
We're
developed.
still early in the process. All technology and evolution, goes through different journeys. We do have production level kind of capability that's been researched and developed and actually used. And there's still maturity, of course, that exists and has to continue to grow. Yeah. But it's gone from just the conceptual stage to reality, right?
Absolutely. The consortium worked really hard to actually have a demonstrator, which usually the previous phase was to develop the concept, and this new phase for the next 2 years is to develop a demonstrator. We actually did that in the previous phase. So what we're trying to do now, really, as I was saying before, when we want to deploy these kind of systems, we need to gather operational evidence through an operational environment to be able to show the feasibility, the validity of those systems to the regulator, right? So this is what we're trying to do at Cranfield. Our global research airport, as we say, is working with a number of those partners from Flight to Plan to deploy that in our airfield with certain nodes. So Cranfield has its own air traffic control, its own airfield, its own airline. So we're working with a number of partners from Flight to Plan to deploy that at Cranfield.
Okay. Well, let's talk about Cranfield for a minute, because I believe that Cranfield, is instrumental in bringing us to the next step in this kind of an area. And so, tell me a bit about Cranfield. Who is Cranfield, and what's its history, and what are you doing there today? How does Cranfield fit into this? Cranfield University fit into this equation?
So Cranfield University, first of all, is a postgraduate only university. So we are focusing a lot and mainly on research. We have the beauty and the opportunity to have a live airport in our ecosystem. So we can do quite a lot of things of bringing partners together where they can't really do testing in their own busy airport. For example, in this case, Flight to Plan. Although we did demonstrate a use case at Heathrow during that program. But basically what we can do is test things in a less busy environment that are transferable and with lessons learned that transferred into the busy environment.
And I understand that you've also implemented some technology in like the air traffic control tower and things like that. Don't you have some advanced technology that you're utilizing there at the airport facility?
So we have a remote tower, so a digital tower that we mentioned before. So basically this is a digital view through cameras of the outside view for air traffic controllers. So you don't necessarily need a air traffic control tower anymore. You can kind of control from wherever in the world you are, while we control 40 meters from the airfield. But actually this digitalization of the view allows us to then display a number of information feeds quickly to the controllers to be able to take better decision, quicker decision, less thinking, executive decision time.
Yeah, and it isn't that much of a imagination to think about doing that, because we have centers which cover large regions of the world and of the U.S. and of Europe, and they're not visually looking at the aircraft. They're in contact and controlling aircraft from remote locations. So why wouldn't we be able to do it with an air traffic control tower? Yeah.
100%. The only thing I would say is when you control en route radars, you have much more separation. You have much more time to respond. And as we know, the most critical phases of flight is landing and taking off, right? This is where most accidents happen. So actually being able to digitalize those kind of operations during those phases of flight takes much more, as I said before, change management, evidence, and so on. But there's a number of those systems installed. So now we're getting better and better and more
So
experienced.
let me ask you this, is that what is it going to take for us to go to the next step? What do we really have to do, in order to be able to do full implementation of these kind of technologies, for air traffic management? What's next?
I think it's important still to work all together, right? So no one can solve all the issues together. So collaboration is really, really important. Sharing of lessons, right? Which we don't really see much in that industry. Air traffic management has lessons learned, has just culture, because they have that process of really notifying, raising any incident, anything that they can learn from any minor incident or major incident. They raise it. But in uncrewed traffic management, because of course it's the race of who will be first, who will be better, there's less of the lessons learned. And actually the programs as Future Flight, those consortia methods of projects allows that kind of sharing of knowledge, of course, within the consortium itself. And what we're trying to promote is, well, throughout the consortia, throughout the program, we should be better at sharing our lessons, collaborating, understanding who is developing what and how we can bolt those solutions together.
And does the consortium remain active today?
Not as a consortium altogether, because we weren't successful in the phase 3 flight, but in more small ways. So we are active in the way we still collaborate together, but not in the context of Future Flight. As I said, we're working with a number of partners to deploy that system at Cranfield Airport and gather operational evidence. So whoever wants to get involved, please contact us.
Well, Dimitri, we've had roughly 110,000 people that have watched these broadcasts over the last 6 weeks. And so the people are interested. All right. Now, if somebody wants to join in on this conversation, how can they get involved? How should somebody get involved if they're interested in this? If they're a business or an individual or an airline or a regulatory agency, how can they get involved?
So I'll leave my details at the end here. Just contact us. We are the Center for Autonomous and Cyber Physical Systems, the Global Research Airport at Cranfield. Get in touch just to understand exactly what's the requirement, how you can get involved. But we're always open to collaboration, always open to learn more, share more, take the industry forward in a sense.
Hey, does Cranfield have any remote learning programs?
Yes, absolutely. So we have remote learning. I thought you were saying part-time. I think
so if somebody doesn't live in the UK, do you have any programs where they can, remotely get engaged in postgraduate, programs or?
Definitely PhDs. For MSCs, we try to do more face-to-face because this is where really our value comes out. But we definitely have opportunities for remote learning in a case-by-case basis. But I think for us, really, the benefit is our facilities.
Yeah, we have people all around the world that are watching. So I just wanted to know. So if people are located in the local region, you probably know about Cranfield. But if you don't, reach out to Dimitri and, you can have a conversation with him. There's his email there on the screen. Definitely we're interested in the concept or the ideas of advanced air mobility, such a growing idea and interesting how we've now put together, digital transformation, blockchain, distributed ledger technology, and aviation. So listen, everybody, the reason that we're doing this is that I want you to know about the things that are happening in the industry. I want you to be aware of where you can get help and how we can collaborate together to be able to help create operational efficiencies within, our industry, our aviation industry, all while maintaining even a better safety record as we go forward all the time. And so, Dimitri, I really, really appreciate what you're doing in the industry and how you're helping bring this with your enthusiasm and, the consortiums you're involved in. And what you guys are doing is really great to bring together digital and aviation. I just wanted to thank you so much for your initiatives in this area.
Pleasure to be part of this. And actually, as I said before, it's all about collaboration, right? So Cranfield is one of the players of a collaborative team at the end of the day.
Hey, Dimitri, if I were to ask you a question, what are you the most excited about at this time in aviation and digital? What's exciting to you?
I think this is where we are in a great phase of the transformation of air traffic management, right? So all those technologies that we've been discussing for so many years, artificial intelligence, intelligent systems, blockchain, and so on. Actually, we're in a point where we can deploy those systems now, right? There's no computing power issues anymore. There's no such constraints. It's more about, okay, so how we make sure that we can put them into operational, transition them into operational environment with certification in mind. Certification requirements that are in existence currently, but actually working with the regulator to do that. So I think in the next couple of years there'll be really, really interesting things coming out of it.
Good. And I appreciate, you and Cranfield University and what you're doing to contribute to that. Thank you so much. Hey, listen, before you drop off, I just want to tell everybody that, I'm Mark Schultz with DigitalAircraft, and we're passionate about aviation and digital, and we're passionate about implementing of aviation and digital. And if you want more information, reach out to me. There's my email address on the screen. If you'd like to possibly be on this live broadcast, we do them frequently. I've done 1,000 live broadcasts in the last 18 to 24 months. And we're just passionate and excited about it. You can reach out to me and we can have a conversation, about that. Reach out to me on LinkedIn or my email. Hey, listen, one more reminder about what's next this week. 2 days from now, we have a live broadcast on Friday, which is with a company called eVTOL. And what excites me about eVTOL is they're bringing together NFTs, blockchain, cryptocurrency, and the availability of private jet transportation all together. And it's really an exciting topic. And I think you're going to want to watch it, because what they're really doing is they're bringing private jet, business jet transportation available to many more people by doing that. So don't miss that one on Friday. Dimitri, thanks for joining us. I really appreciate you being with us today. And I wish you the best in your adventures. And if there's anything that we can do to help, be sure to reach out to us.
It was a pleasure. Thank you for having me.
Very good. Okay, everybody, fair winds and following seas. Thank you for joining us, and I'll see you on our next live broadcast. Bye for now.
Cheers.